Dealing with an existing electrical installation that lacks a proper equipment grounding conductor, specifically for a lamppost circuit, presents a common challenge. The goal is to introduce a ground wire, also known as an equipment grounding conductor or EGC, to the switch leg running to the lamppost, while minimizing disruption to the existing structure, particularly avoiding damage to the wall and paint. Several approaches can be considered. Firstly, consider using a surface raceway. This involves installing a surface-mounted electrical raceway, also called conduit, from the existing 2-gang box in the living room down to the basement. This raceway will serve as a protective channel for the new 14/3 wire that will be installed. Run the new 14/3 wire through the raceway. One conductor will be the hot feed, one will be the neutral, and the third will be the equipment grounding conductor, providing the necessary ground for the lamppost circuit. Connect the conductors to the appropriate terminals in the existing 2-gang box and at the junction box in the basement, where the underground feeder, or UF cable, connects to the lamppost. To minimize the aesthetic impact, conceal the raceway with paint or paintable molding. Select a color that closely matches the wall, or use paintable molding that can be customized to blend seamlessly with the existing decor. Secondly, explore the possibility of using an existing wall cavity. This approach involves investigating whether there are any accessible wall cavities that can be utilized to run the new 14/3 wire. Carefully assess the wall structure to identify any potential pathways, such as spaces between studs or around existing pipes or wiring. Once a suitable cavity is identified, carefully cut a small hole in the wall at the bottom of the existing 2-gang box location and another hole at the point where the wire will enter the basement. Use a fish tape, which is a flexible tool designed for pulling wires through confined spaces, to guide the new 14/3 wire through the cavity from the living room box to the basement entry point. This requires patience and careful manipulation of the fish tape to navigate any obstacles within the wall cavity. After the wire is successfully run, connect it to the appropriate terminals in the existing 2-gang box and the basement junction box. Patch and paint the holes to restore the wall surface. Use a patching compound to fill the holes and sand it smooth to create a seamless finish. Apply paint that matches the existing wall color to conceal the repair and maintain the room's aesthetic. Thirdly, consider installing a new electrical box. This option involves creating a new opening in the wall near the existing 2-gang box. Carefully cut a new hole in the wall, ensuring it is large enough to accommodate a new electrical box. Install the new electrical box and transfer the existing conductors from the old box to the new box, maintaining the original circuit configuration. Run the new 14/3 wire from the new box down to the basement, providing a dedicated circuit with an equipment grounding conductor for the lamppost. Connect the conductors to the appropriate terminals in the new box and the basement junction box. Patch and paint the new hole to match the wall. As with the previous method, use a patching compound to fill the hole and sand it smooth before applying paint that matches the existing wall color. Fourthly, explore the use of a wireless switch. This innovative approach eliminates the need for running new wires through the wall or ceiling. Install a wireless switch in the living room that communicates with a receiver located in the basement. The wireless switch can be mounted in the wall in place of the existing switch, providing a convenient and user-friendly interface for controlling the lamppost. Wire the switch to the existing conductors in the 2-gang box, ensuring a proper connection. If necessary, install a new ground wire to the existing Romex to provide an equipment grounding conductor for the switch itself. Connect the receiver to the new 14/3 wire in the basement. The receiver will act as an intermediary, receiving the signal from the wireless switch and controlling the flow of electricity to the lamppost. This option offers a clean and efficient solution for adding a ground to the lamppost circuit without disturbing the existing wall structure. This approach would require the installation of a new circuit breaker in the electrical panel for the new 14/3 circuit that will power the new lamppost. In any of these scenarios, it is important to energize the circuit by switching off the corresponding circuit breaker in the electrical panel before commencing any electrical work. This is a critical safety precaution that prevents electrical shock and ensures a safe working environment. Use appropriate personal protective equipment, or PPE, such as safety glasses and gloves, to protect against potential hazards during the electrical work. These safety measures minimize the risk of injury and ensure a safe and successful project. When working with electrical wiring, it is essential to adhere to the National Electrical Code, or NEC, and any local electrical codes and regulations. The NEC provides comprehensive guidelines for safe and proper electrical installations, covering aspects such as wire sizing, circuit protection, grounding, and bonding. Local codes may have additional requirements or amendments that must be followed. Ensure that all wiring connections are made with approved connectors and methods following the manufacturer's instructions. Proper connections are crucial for ensuring electrical safety and preventing loose connections, which can lead to overheating, arcing, and potential fire hazards. After completing the wiring, thoroughly test the circuit to verify proper operation and ensure that the ground fault circuit interrupter, or GFCI, protection is functioning correctly. Use a multimeter to measure voltage and current to confirm that the circuit is operating within acceptable parameters. A GFCI tester can be used to verify that the GFCI protection is working as intended, protecting against ground faults and electrical shock. If the existing Romex wiring in the 2-GAN box has an undersized equipment grounding conductor, consider replacing it with a new cable that has a properly sized equipment grounding conductor. According to the NEC, the size of the equipment grounding conductor must be appropriate for the size of the circuit conductors. Replacing the undersized equipment grounding conductor ensures that the grounding system is effective in providing a safe path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. When running new wires, carefully secure them to the building structure using appropriate fasteners, such as staples or cable ties. This prevents the wires from becoming loose or damaged and ensures that they are properly supported. Avoid over-tightening the fasteners, which can damage the insulation of the wires. If the existing metal 2-GAN box is not properly grounded, it is essential to bond it to the equipment grounding conductor. This can be achieved by connecting a bonding jumper wire from the metal box to the equipment grounding conductor in the box. Bonding the metal box ensures that it is at the same potential as the grounding system, minimizing the risk of electrical shock if a fault occurs. Consider using arc fault circuit interrupter, or FSI, protection for the circuit, especially if it serves living areas. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. FSIs trip the circuit breaker when an arc fault is detected, providing an extra layer of protection against electrical fires. The NEC requires FSI protection for many circuits in residential dwellings. When selecting wire and cable, choose products that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, or UL. UL listing indicates that the product has been tested and meets safety standards. Using UL listed products ensures that the electrical system is safe and reliable. If the lamppost is located in a damp or wet location, use underground feeder, or UF cable, for the wiring that runs underground to the lamppost. UF cable is designed to be installed directly buried in the ground and is resistant to moisture and corrosion. Using UF cable ensures that the underground wiring is protected from the elements and will provide a long-lasting and reliable connection to the lamppost. When connecting the wires to the lamppost, use weatherproof connectors and enclosures to protect the connections from moisture and corrosion. Weatherproof connectors and enclosures are designed to seal out water and prevent it from entering the electrical system, which can cause corrosion and electrical failures. Consider installing a photocell control for the lamppost, which automatically turns the light on at dusk and off at dawn. A photocell control can save energy and provide added convenience. The photocell control can be installed in the lamppost or in a separate enclosure. When working with electrical systems, it is always best to consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with applicable codes and regulations. Hiring a qualified electrician ensures that the electrical work is done correctly and safely, minimizing the risk of electrical hazards. If the existing wiring is old or damaged, consider replacing it with new wiring. Old wiring can become brittle and cracked, which can increase the risk of electrical shock and fire. Replacing the old wiring with new wiring ensures that the electrical system is safe and reliable. When working with electrical systems, always follow the manufacturer's instructions for all products and equipment. The manufacturer's instructions provide important information about the proper installation, operation, and maintenance of the products and equipment. Following the manufacturer's instructions ensures that the electrical system is installed and operated safely and correctly. If you are not comfortable working with electrical systems, it is best to leave the work to a qualified electrician. Electrical work can be dangerous, and it is important to have the knowledge and skills to perform the work safely. Hiring a qualified electrician ensures that the electrical work is done correctly and safely, minimizing the risk of electrical hazards. Remember that electrical codes and regulations can vary depending on the location. It is important to be familiar with the applicable codes and regulations in your area before starting any electrical work. Contact your local building department or a qualified electrician to learn about the specific codes and regulations that apply to your project. Always disconnect the power before working on any electrical circuit. This is the most important safety precaution to take when working with electrical systems. Disconnecting the power eliminates the risk of electrical shock and ensures a safe working environment. Use a voltage tester to verify that the power is off before starting any work. If you are working on a circuit that is connected to a GFCI, test the GFCI before starting any work. A GFCI is designed to protect against electrical shock, and it is important to ensure that it is working properly before starting any work. Use a GFCI tester to verify that the GFCI is functioning correctly. When working with electrical tools, use insulated tools. Insulated tools are designed to protect against electrical shock, and they are an important safety precaution to take when working with electrical systems. Inspect your electrical tools regularly to ensure that they are in good working condition. Replace any tools that are damaged or worn. Wear safety glasses when working with electrical systems. Safety glasses protect your eyes from flying debris and other hazards. Wear gloves when working with electrical systems. Gloves protect your hands from electrical shock and other hazards. Keep your work area clean and organized. A clean and organized work area is a safer work area. Avoid distractions when working with electrical systems. Distractions can lead to mistakes and accidents. Take breaks when needed. Working on electrical systems can be physically and mentally demanding. Take breaks to avoid fatigue and to stay alert. If you are unsure about anything, ask for help. It is always better to ask for help than to make a mistake that could lead to an accident. Consider the specific requirements of the lamp post when selecting the appropriate wiring and components. Ensure that the wiring is properly sized to handle the load of the lamp post and that the components are rated for the environment in which the lamp post is located. For example, if the lamp post is located in a coastal area, use components that are resistant to corrosion from salt water. Consider the aesthetic impact of the wiring and components. Choose wiring and components that blend in with the surroundings and do not detract from the appearance of the lamp post. For example, use wiring that is the same color as the lamp post or use components that are concealed from view. Consider the long-term maintenance requirements of the wiring and components. Choose wiring and components that are durable and require minimal maintenance. For example, use wiring that is resistant to damage from sunlight and use components that are easy to access for maintenance. Remember to consult the manufacturer's specifications for the lamp post to determine the appropriate wiring and component. The manufacturer's specifications will provide important information about the electrical requirements of the lamp post. Always follow the manufacturer's instructions when installing the wiring and components. The manufacturer's instructions will provide detailed information about the proper installation procedures. If you are not comfortable working with electrical systems, it is best to leave the work to a qualified electrician. Electrical work can be dangerous, and it is important to have the knowledge and skills to perform the work safely. Hiring a qualified electrician ensures that the electrical work is done correctly and safely, minimizing the risk of electrical hazards. Brett's proposed approach involves disconnecting the existing metal connector from the Romex bundle. Carefully pull the existing Romex wires out of the box, leaving the equipment grounding conductor connected. Cut the existing Romex wires and discard the portion without the equipment grounding conductor. Feed the new 14/3 wire into the box and connect it to the appropriate terminals. Use an inline wire connector to attach the equipment grounding conductor from the old Romex to the equipment grounding conductor of the new wire. Reassemble the box with the new wire in place and install a new metal connector. Test the circuit to ensure proper operation. This method attempts to retain the existing equipment grounding conductor from one of the Romex cables while introducing a new 14/3 cable for the lamppost circuit.